welcome back to the Hakian YouTube channel. So today we're going to be working on lines with intercepts and just working out how to draw our linear graphs using our linear equation. So let's get started. So today's learning intention is to understand how to sketch lines with one intercept and find their appropriate linear equation, which we will go through. You need to be able today to know that the lines through the origin only have one intercept, and we're going to tell you which one. You need to be able to either find the linear equation or you can draw the linear equation correctly on a Cartesian plane. So right before we get started, there's a few things that you just need to know. So there's just some vocab which I'm going to go through with you. So a vertical line, okay, is just a straight line that goes down, all right? I would use a ruler, but unfortunately I don't have a ruler on my trackpad, so I'm just going to have to do with what I have. A horizontal line, okay, is a line that goes this way, okay? Parallel lines are lines that are next to each other that never touch. So if I was to continue drawing this line, upwards, these are just arrows, okay, they would never be touching, but they're next to each other, and we call that a parallel line. So before I get touch onto what an x and y axis is, I'll just quickly draw a Cartesian plane. Now, that's not very straight. I'll try to draw a straight one, but okay. So this. Hang on a second. Sorry, just a bit of having a bit of difficulties drawing straight today. So this is a bit of a Cartesian plane where you've got your x-axis and your y-axis. Okay, so that's your x and y I've drawn. Normally in a Cartesian plane, you just see, you just write x and y. You don't have to write axis. I'm just writing axis for you so that you're able to see which line and arrow is the x and y axis. All right, so the origin, okay, is this middle point here. So the origin point is 0, 0. So the line touches 0. Okay, so this is 0. So on the x-axis, our positive numbers are this way. So it'd be, 1, 2, 3, 4. I'm just doing hypothetical. And then our positive numbers would go up. So 1, 2, 3, 4. All right, it doesn't matter which side you put the numbers on. I usually just do them like how I've done it. And negative numbers would go this way and that way. So this is positive 1, then the opposite side would be negative 1. If this is positive 2, this side is negative 2, and that's negative 3, okay? So if this is positive 1, this is negative 1, and that's negative 2, and it looks like that, all right? So I've just shown you what side is positive and what side's negative. So the origin is 0.00, which is the middle point there. Okay, that's the origin. So the linear equation is written as y equals mx plus c. And I will talk you through as to what, each of these mean. So you just need to know this because the more times that you hear it, the better you'll be familiar with the equation. So the x-intercept, okay, is where the line or the graph that you've sketched touches the x-intercept touches the x-axis. All right, so if I drew a line, I'll just do it in a different color so you can see. Do it in blue. If I did a line, that went like this and went like that, okay, so the x-intercept, so where the line touches the x-axis. So this is the x-axis, this horizontal line here, and it touches the x-axis at 1. So for this one here, we can say that the x-intercept is 1. All right. Now the y-intercept is where the graph, okay, touches the y-axis. So, and we can see that this vertical line here, which I'll do in green, okay, this is the y-axis. So the line touches y at -2, which we've just seen here. So we can say here that the y-intercept is -2. Okay, so if you need to pause the video at any time, feel free. Okay, so I'm just going to quickly show you some linear equations with visuals that have ruled lines. Unfortunately, I don't have these because I don't have a ruler. So a vertical line, x equals b. So you're probably like, what is b? You know, b could be any number, all right? So before I had, you know, positive numbers, 1, 2, 3. If I drew a line down here, oops, that's not a very good one, like that, let's say it was going through 2, okay, we would call this line x equals 2 because you're saying that this line is when x is touching 2. So x is 2. So that's why this is x equals b. So it says x equals b is parallel to the y-axis because I said parallel lines don't touch each other. They don't touch each other. Now you can know that b is a constant, so a number, okay? And we know that the x-intercept, so where the line touches the x-axis, okay, is at b. Okay, this question has just put letters instead of numbers. So we're just going to do the same over here. So the horizontal line is c. So it could be like I've done before, you know, x, y. If I had 1, 2, 3 and I put 2 there or 1 there or, you know, 1, 2, 3, because this is origin. If I did a line there, we would say y equals 1. Okay, that's the same, it means the same thing. As in, c is just any number where the line touches the y-axis. So this line is parallel to the x-axis, meaning that this blue line and this black line here, because this is the x-axis, is parallel, meaning they don't touch. They could go on forever, but they don't touch. So c being a constant, which means number, and the y-intercept is c, just like how I've drawn here that the y-intercept is 1. Remember, intercept is when they touch the y-axis. So, lines through the origin of 0, 0. So this is 0, 0 right here, okay? So when the intercept, the y-intercept is 0, you don't need to write plus c. So do you see how this question just says y equals mx? So y equals mx plus c. This c is the y-intercept, okay? M is the gradient, okay? And that's what you really need to know. So if this number here is 0, you don't need to write it. If 0, okay? Sort of like, you know, if we write 1 plus 0, we don't write, we just say 1 plus 0 equals 1. We don't go 1 plus 0 equals 1 plus 0. Okay, we don't write that. Right, so you can see that all of these touch the same y and x intercept, but they have different gradients. So see how the first number in front of x is always different? So what's the imaginary number in front of x? 1. Okay, that means that they actually all mean something different. So we're going to quickly sketch these real quick. So when it says y equals -1, the first thing you need to do is draw your Cartesian plane. Obviously straight, because I don't have a ruler. So you draw your Cartesian plane, you put your x and your y, and then what you do is you substitute, so you draw your numbers in, so 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, you always need to remember that these sides are positive, going up and going to the right. Okay, and I'll do the other side in a different color. Okay, so these are negative. The reds are negative. Okay, so these are positive. Now it says y equals -1. So what you need to do is you need to find -1 on the y-axis. So the y-axis is here. So y -1 is about here. And all you have to do is just draw a line through y equals -1. Okay, and you always must need to make sure that you write and you label that line, otherwise I don't know what that is, or your teacher doesn't know what it is. So if we were to draw another Cartesian plane, okay, I need you to get into the habit. 1, 2, 3, 1, 2, 3. They should be evenly spaced out using a ruler. So this is negative, these are positives. Okay, so right, hang on. 1, 2, 3. Oh, 1, 2, 3. Okay, so you got to find x equals 3 on your Cartesian plane. So you need to find, this is the x-axis, so you got to find x equals 3 on your x-axis. So when x equals 3, it's about here. So just put a dot there so you know. Get a ruler and draw a line through that. Make sure you put 2 arrows up and down and you write x equals 3. Okay, so a few things that you just need to remember to do. You need to make sure you label your x and y axis. You need to make sure your intervals, you use a ruler to do your intervals. You need to make sure you label your graph with the equation. Okay, I'll just write label axis. Okay, and you need to make sure that you use a ruler to draw your Cartesian plane, CP. And you have to show the intercept. Okay, so intercept meaning that the graph touches the x-axis at 3. So the x-intercept for this graph would be 3. What's the y-intercept? Well, it didn't touch the y-axis, did it? But this point here, right here, okay, is when this line it has a line that connects to the y-axis, so the y-intercept wouldn't exist, okay? As long as this line isn't touching the y-axis, there is no y-intercept. But when you write coordinates, we will work out how to write and fit the origin in it. Okay, so let's sketch the graph. So the linear equation graph is y equals mx plus c. Okay, so we know this is the gradient. We know this is the y-intercept. Okay, so the first thing you need to do is you can see that there's no y-intercept. Okay, so that means we know that the graph, okay, touches through the origin. Now, in order to find out what coordinates there are, we need to substitute values in. What do I mean by substitute? So, let's say 1, 2, 3. Okay, remember these are positive. These ones are negative. Oh my gosh, my line just disappeared. Hang on. I'm not sure why my line disappeared. Okay, so what you can do is you can pick a value. So let's say that's my equation, right? Let's say I want to pick, like, I don't know, when x is 1. Let's say I pick 1 here. So I have to put the value of x, because 1 is on the x-axis, into this equation. So it becomes y equals -2, 1. See how I've just substituted the 1? Now the imaginary symbol between -2 and 1 is times. That's what makes them best friends, all right? So y equals 2 times 1 is 2, and negative and a positive, because we know this is positive, there's no negative, is a negative. So when x is 1, y is -2, okay? So what we can do is we can plot that. So this is what we call a coordinate, okay? And the x coordinate is always written before the y with a comma. So it's always x coordinate, x number, comma, y. So open bracket, X number, comma, Y number, close bracket. So now we can put X as 1 when Y is negative 2. I'm just going to do that in a different color. So when X is 1, Y is negative 2. So it should be about here. Okay, because when X is 1, Y is 2. So that's this one here. Okay, and we know that there's no y-intercept. So that means it touches the origin. Okay, so that means it's here. And if I draw a line joining the two dots, because I'm awful at that. Hang on, this is very awkward for my hand. You would use a ruler, okay, to join it, and then you write the equation. It doesn't matter if it's down here or up here, okay, y equals negative 2x. So when it's a negative, okay, the graph usually goes this way. If the graph is positive, it will go this way. This way, this way. Okay, this is positive graph. Negative graphs, okay, go this way, okay? And we just need to wrap our heads around the direction that is required for the graphs. So now I want you to try a few from your book, and thank you for watching today's video. And ask your teacher any questions if you have any issues. Thank you.